Okay, friends, let's look at another example of how to use this idea of expectation or average expected value with weighted means. Let's look at Powerball. Powerball is a pretty popular game in our culture. You pick a bunch of numbers and a Powerball, and if you match certain numbers of those numbers, you win certain prizes. So what I did was I actually visited down here on the site. They give you all kinds of stats about, your prizes and your odds charts. And I took those and I copied them into Excel. So here's the idea. The jackpot right now is $114 million. If you buy a ticket that has all 6 numbers correct, so if on May 23rd, if you had picked 2, 8, 18, 21, 23, and a Powerball of 16, then you get $114 million. Now, I'm going to leave out a couple of very important things. I'll mention them later, but the important things are, number one, taxes. You don't actually get to keep all that money. The other thing, too, is, and we'll talk about this later on, too, the idea of splitting jackpots. Yeah, I'll come back to that later. So the odds of winning the jackpot, you have to get the one ticket out of 292,201,338 tickets. That's the odds. Anybody wants to figure these numbers out over here, I'll give you some extra credit points. Very, very small likelihood that you're going to get that jackpot ticket. But the thing about Powerball that's appealing is that you don't have to get all 6 numbers. If you just get the first 5 without the Powerball, they give you $1 million before taxes. You're more likely to get that too. I mean, this is still a very, very small number, but it's about, twice as likely as getting the jackpot. So $1 million, there's the chance. If you get 4 of the white balls plus the Powerball, you'll get $50,000. There's the chance of that. If you get 4 of the white balls without the Powerball, they'll give you $100. There's a chance of that. 3 plus the Powerball, they'll also give you $100. There's a chance of that. Just 3 without the Powerball, you get 7. And there's the chance. 2 with the Powerball, they'll give you 7. There's the chance. 1 with the Powerball, they'll give you 4. There's the chance. 0 with the Powerball, they'll give you 4. There's the chance. So you might be tempted to be like, oh my goodness, I can work the math on this. I can work the math. I can do this times this, plus this times this, plus this times this, and you can. You can. You just shouldn't, because here's, unfortunately, what the Powerball company will not tell you. If you add up all these probabilities over here, I'm going to highlight them right here. I'm going to have you look down here in the bottom. You'll notice that only adds up to about 4%. Now, how can that be? This should add up to 100%. Remember, with the last example, I either live or I die 100% of the time. With the raffle, you either win or you don't 100% of the time. How can this only be adding up to 4%? It has to add up to 100%. Because what they haven't told you is you might completely lose. You might notice up here, there's no option for match 1 without a Powerball. If you buy a ticket and get 1 number to match without the Powerball, they don't give you anything. Or you buy a ticket and no numbers match whatsoever. You don't get anything. So if you completely lose, you don't win anything. And it gets a little bit worse. I included a column in here called Actual Payout. Sure, they're calling this the payout, but really, if you think about it, you have to take out the cost of buying the ticket, which is $2. So we have to take each of these prizes and subtract $2 from it. Yeah, it's fine. Those are the actual payouts, and you'll notice that this one's negative. That's very important. For the same reason the insurance company needed to have a negative, this has to have a negative. And more importantly, the probability over here. So I'm going to figure this out. I know that we added these up and said it was about 4%. I'm going to use a little Excel trickery here. I'm going to go 1 minus the sum of all of these. And that'll tell us what is, yes, just about 96%. So really, I'm going to hide this column. The actual payouts of all these things are given to us right there. I'm going to make the fonts gray, because really this is all we need to know. So let's look at the average payout per Powerball ticket. That is a mouthful. the average payout per Powerball ticket. I'm going to use that sum product command I used last time. I'm going to equal sum product, and I'm going to select first these, then comma, and then these, and I'm going to let Excel work them, and look at that. Look at that. It's a loss of $1.29, which is, Powerball knows this. They know this has to be negative. It has to be negative because Powerball needs to make money. It's a business. Now, something to think about with Powerball. I mentioned earlier that we ignored things like taxes. And this gets even worse when you consider taxes because these prices go down. But something can actually go up over here, the jackpot. Okay, so for example, let's just suppose the jackpot increased to something like, I don't know, $300 million. All of a sudden, you might have noticed the average is now less negative. These prizes down here will never change. Those are fixed. The jackpot changes, though. Let's suppose the jackpot goes to $400 million. I got enough zeros. Yeah. Okay, look, it's getting less negative. It's heading towards zero. Let's suppose it goes to $500 million. Oh, look what just happened. The average payout per ticket is now a positive 3 cents. Why do I bring this up? You still have the same odds of winning. The odds aren't going to change. This is mathematically identical no matter how big the jackpot is. You might notice that when the jackpots get really big, and I forget what the largest Powerball jackpot ever was. It was probably close to this. It's probably close to $500 million, if not a little bit more. More and more people start to play. It's almost like people have like an internal mathematical probabilistic statistical switch that gets thrown that makes them think, oh my God, if this jackpot gets big enough, the average switches over to positive. Granted, it's an average. You have no more chance of winning than you did before. You're only going to win 4% of the time. And when I say win, most of the time, you're going to win very small prizes. But if that jackpot gets big enough, this average can head positive. Now, what we just did here in this spreadsheet is kind of fun. It's called Actuarial Mathematics. This is what actuaries do all day long. These are the folks that set insurance rates for companies. They have to play with these numbers and figure out the odds as best as they can, and then set the payouts based on those odds. It's actually really fascinating work. And if I wasn't so happily teaching you all this kind of stuff, I would go do that as a side hobby. Let's look at one more example.